And this is really kind of key, and this came up on the quiz. Area between the graph and the horizontal axis. I didn't like how it said under, because then do we just shade all this stuff? I only shade the boxes that are between the graph and the horizontal axis. The units of that area would be meters, and so it's telling us about the displacement. So when we slide onto the back here, you're given position versus time, data table, and you need to plot position versus time, plot velocity versus time, and then plot a motion map. And then it wants to know about the displacement from various times, the average velocity from various times, the average speed from various times. So that's where we're at. So go ahead and get after that. If you don't have that plotted yet, if you need the sheet because you were not around, let me know. But that's where we want to go next. All right. Got that graph.
Peaches, everything better today?
Yeah.
Since I had to be alone on Friday.
Wait, which sheet is it? Don't we already have that?
Period 2.
We already have this one. You started it. Get out your old one.
Why did you give me one?
Isn't it the same one? Because we didn't have it out, so we assumed we didn't have one.
Kind of breathe.
Isn't it the same thing? Is that thing the same as this one that you just handed?
Probably, yep.
Okay.
Yep.
That's not like for 1 minute.
Why can't you wear that? It's kind of annoying. Like when you have performance that you have to like post out.
Which worksheet is this? Worksheet 4.
I think I have a lot, but you couldn't use mine.
Well, technically.
She okay?
It's so loud.
Yeah, that was really loud to ask someone to do it.
Grace? Dude.
Here we are 10 years later.
That's good, man. In softball, you gotta be loud, right?
This is not softball, this is this.
Yeah, but it's funny because you know Lorena. You know everybody, right? So you know Lorena.
Sure, the rain that goes here?
Yep.
Yeah. You know who that is.
Yeah.
She's dating Robbie. Now you know who it is.
Okay.
Yeah.
She's my daughter's swim instructor, and she was like the quietest person last year in class, but
She's not quiet.
not in swimming. She's got to be loud, so I just sit over there and giggle. She's very loud.
Sorry, did we get this on Friday?
We did.
You want another one, Grace?
2.
I have another one too. Because we didn't have our sheets out, so I think he assumed that we didn't have one.
I was just trying to be helpful.
Yeah. What'd you say? Tell me. Is he sitting there?
No, because Grace.
You're not loud. Okay.
I bet Kate's hair can be loud.
But you said loud?
I said I bet you can be loud.
Can I be loud?
If you play softball, you have to be loud.
Honestly, no.
Got it!
My attitude is loud.
Yeah, oh my gosh. Have you
What does
not
that even
noticed
mean?
that about her?
I don't even know what
She
that
has
means.
an attitude. Alright.
I'm graphing.
He's busy.
1, 2, 3, 4. -1, -2, -3, -4, -5. It's going 2, then it's going 0, then it's going 3. It's going 0. Then it's going, what is this? 1, 2, 3. Oh my gosh. 1, 2, 3, 4, 5, 6? No. Oh, you donkey. What? What did I do? Oh, I don't like this.
What?
For it's at 7. Oh, man.
Did you say
First one.
what does that mean?
I spoke coffee. I don't know.
Uh-oh.
Sorry, the sentence. Oh. Anatomy, no. Could ask
You know molecules?
I know what they are. Could ask me
Which of the following molecules contains some covalent?
Mr. Carter would be so disappointed.
Do you want to say something?
That's pretty good.
Alright, so let's pair it up.
Why are you asking me this?
You know what that is?
Go ask me. Oh, so it's a line.
Covalent bonds.
Those are bonds that share things. Right?
Sounds like cohabitate, yeah. In the valence level, probably. I heard valent in there. So.
Sorry.
Tomorrow? Or you can call yourself in?
Be done on the physical process.
I don't really either. Just go to the flexi shed.
Hey, do you know how to hold yourself in gravity?
I bet Riley knows how to do it. Riley, coach him
You
up.
go to Flexi Schedule.
He said I don't want to.
It's just so much easier if you do it for me. No, not happening. I'm lazier.
Check out his huddle week 105.
All right, what's going on here? What's up, buddy? Oh, boy.
I'm a little confused. So, like, is each of these lines supposed to be like another meter?
I think. you
So
might-
it'd be
or you
like,
could
but
do
it goes
two,
up to,
yeah,
okay, so you can
right.
make it like 2.
Yeah.
And then, so I'm guessing you kind of want the lines to like match up with like how many meters
The
per
dots
second. The
should
dot.
be at the right spots. The
Right.
arrows should be like linked
Okay, so that
accordingly.
So they should. I want to
stop
usually a
that.
lot
Or
more.
should go a little bit longer.
Yeah, in my shakes that I use sometimes in the morning there's almond butter, but I've never just eaten it like on. Do you like just put it on things? I didn't know it was good plain. Honestly, I didn't know.
It tastes like peanut butter.
Oh my goodness.
And then,
I only put it. Yeah, it is healthy. I only put a tablespoon of it.
so this would be like 1 second, right? And then would I draw a line from this one or draw another
I'm not
dot
a
and then
huge
do a
fan
line
of
from
peanut
that
butter
one?
in general.
Because it only stops
That's a
for
good question. I would talk to your friends and neighbors and see what
Okay.
they think, and then we'll
Oh,
get
you're
that.
my neighbor.
Perfect. Go over there and talk to her over there.
I always.
Or
Like,
talk to
I'm
her.
on before, I
Yeah.
always go
Yeah.
I want to know how it's doing it.
Go talk to her about motion
I can
maps,
help
and
you
then she'll
with
talk to you about that.
That's all I understand about. I can
Yeah, I noticed those at church last night. What's this? That's a scar.
All right. Boop.
It really can. Is it real?
No.
Okay. It looks good though. No, it looks way better than everybody else's I've seen. It's so
NVY.
funny the first day. And she was like, it looks good. Uh-huh.
Yeah.
She just looked like the same thing as her fingers. She
Yeah.
blended in. No, but the second day it looked fine. Like the first day it was like,
All right, here you are.
and it looks good.
Pair deck is NVYHQ. And over there, we're wanting to know the displacement from 3 to 5 seconds. So we call that change in possession, change in position, 3 to 5 seconds. What do you get for that? Genius. There we go.
What? 45 and 42 on 45. Good job. Thank you. And we just turned in our paper today. I don't know. So the 10 minutes late and didn't have it. So the questions haven't Kiana? Walked in like she was having a
Yep, because she had to stay late and fix it out, which is why I'm assuming she was late. Because India had to do that, she was late. And she was like fine with that. Like the teacher was like, yeah, go find again. That's fine.
That sucks.
probably.
Honestly, she would be.
There goes that good idea.
She's not.
Is she a warm demander?
What is that?
Like warm, like engaging, friendly, but
Yes.
still
No, she just like
wanting the best from you.
the first couple of days, she was like all over the place, and she was like, I promise I'm not usually like this. And now we're like 4 weeks in, and she's the same way.
Oh, that's not a warm demander.
Unorganized, but she's really nice. But she's also my other professor's boss, and I like her way more than her. So
Whoa. Don't need to play favorites. All right. Too late.
Alexis, don't. Do you like your other professor more than Monday, Wednesday?
Monday, Wednesday,
Like
professor.
my
I mean,
Thursday.
Tuesday, Thursday, whatever it is. I don't even know.
Did you just describe someone as raw? Is that good?
Yes. It's raw.
One, two, three, four. There we go. All right, so the question on the pear deck. There's a question on the pear deck. The question on the pear deck is that change in position from 3 to 5 seconds. Pear deck is NBY HQ for the other half of you that need to come join us over there. And the question is, what is the change in position from time 3 to time 5?
It's her. She's just leaving. It's not that hard. Oh, no story there.
Yeah, that was because she essentially advice on something the junior year. And I basically just told her don't overwork yourself. This is sex and this time. She wanted to work like every single night till 10. And I was like, weird, but I didn't want to work. It's great.
Okay, I'm struggling.
I don't know how to do the class.
What are those lines? Like, I could sort of, like, you have to break it up by lines. Like, this line, this line, this line.
But how do you know where it is? Like this.
Oh, it's the slope. I'm so sorry.
Got it. So this one's the slope is 2.
Two?
Yes. I'm so good. Like,
Wait, why?
because like when you go up 1 point,
Four.
listen,
Mm-hmm.
look at my paper. When you go up from 1 point to 1 point, it goes up 2. So the slope is 2. And it's 2 boxes per 1 point. So you would make a line at 2, and I think it would be like 2 boxes.
Wait, can I ask what is the legal?
1, 2, 3, 4, 5, 6. I just went up by 1 because that's what you have up there.
All right.
That's how
So
they
looking
have it
back
on this
here,
side.
we've got 6 meters, negative 3 meters,
So then this one is slope is
6 meters, 6 meters, 6 meters, 6 meters,
3 boxes.
6 meters, 3 meters. Okay.
No, so it's only 1 box. Okay, nope. I don't know how to do it anymore. Oh wait, this one's 0. Sorry.
So how?
This one's 0 in 1 box. So 0 in 1 box. This one is.
Well, why do you put 0 way over there?
What do you mean?
Oh, because
There's a line down the middle. It's velocity. That's like the 0 line.
So hey, friends, if you want to find the change in position from 3 to 5 seconds, you're going to invert that here. You're going to take the position. Oh, come on. You're going to take the position at 5. So I'll call that P5 minus the position at 3, P3. That is 10 meters minus 4 meters. That's giving me 6 meters there for that change of position. Okay? So let's get more than 7 people with it this time. What is the change in position from 7 seconds to 9 seconds going to be then? We still got the same answer? You still got -3?
No, we did it a different way. We just did 2
Oh.
seconds times 3 meters per second equals 6 meters.
That's another way of doing it. That's fantastic. Okay. So Grace, could you say again what you just did?
I multiplied the
Shh, shh, shh.
2 seconds by the 5 meters.
Okay.
3 meters and got 6.
Okay. So effectively what Grace is doing then, yeah, she's over here with this. She's on the velocity time graph, and she's finding the area of this rectangle. This is 2 seconds. The height of this thing is 3 meters per second. So 2 seconds times 3 meters per second. That's how she's getting 6 meters. Okay? So it's the same idea, but that's looking at the area between the graph and the x-axis. Okay? What if you give it a go from 7 to 9 seconds? Oh, and it says, yeah, duh. That's why you did it, because it says using the velocity time graph. So Grace read the instructions. Okay? So try that same idea, but this time from 7 to 9 seconds. If you're using the velocity versus time graph like Grace did, what do you get for the change of position from 7 to 9 seconds?
What did you do for this? 2 boxes at 2 boxes.
And then I was really sorry. I got sick. I was Carson's driving there. She was there. I got to twice on yeah.
She was playing softball.
What does your velocity graph look like?
I was just going to say, it's really fun.
Now I just stand on the side. Oh my god, mine doesn't look like that. Oh, it's negative? She's right. You had it right. You just did it.
Like I was so like that's what we do.
Allie was moving
So this would be negative.
She dinged up her ankle the other week. So.
What?
She dinged up her ankle the other week.
Oh, really?
So, yeah. Because she plays goalie.
Oh.
How can we connect?
Goalie during volleyball. All right, let's see how we're doing on finding the displacement from 7 to 9 seconds. We've got 10 meters, -10 meters, -10 meters, -10 meters, -5 meters. So in terms of variety, we've got 10, we've got -10, and we've got -5. So yeah, but figure out why we got what we got then. There you go. That'll happen. So from the velocity versus time graph. So again, the idea is between the graph and the axis. Boop. And now I want to find the area of that rectangle. So it's again, from 7 to 9, that's 2 seconds. But hey, you got to pay attention to where you're at. We're below 0, so this is going to make it -5 meters per second. So area equals base times height. So I'm going to take the 2 seconds times the -5 meters per second. And that's going to give me -10 meters for that change in position. So what we're looking at here, this is on the essential understandings chart at least. This is what we're talking about 2.4. Finding the displacement from the velocity graph, okay? Determining displacement, the change in position using the velocity versus time graph. you're going to be pretty lucky since we're in the constant velocity particle model. Most of the time, these shapes are going to be rectangles, but you're going to have to key in on a couple of things there. It's not all the boxes below the graph. It's the boxes or the space, the area between, is the key word, wherever that went, between the graph and the x-axis. Okay? And then I was mistaken. We talked about this a little bit the other week. The difference between average velocity, where we're going to look at the change in position, over the time interval, aka the displacement over the time, and contrast that with the average speed, which is the change. I wouldn't call it change. I think I would just call it the distance traveled. And when I talk about distance traveled, again, that's your Fitbit, aka step counter. Divided by the time. Pedometer, if you will, please. Okay? So find those two values. Average velocity from 4 to 8 seconds, average speed from 4 to 8. And let's just do a 2-for-1 over on the pair deck. Yep, 1 second. Let's just do a 2-for-1 on the pair deck, okay? All right. So in the pair deck, answer what is your average velocity from 4 to 8 and what is your average speed from 4 to 8 seconds. All right. I'm going to go get some stuff. Howdy.
Wow, thank you. You just made my whole day. I've been to 2. Maybe 1. I've been to 1. I was going to this week English, so I was on the time, but it wasn't. No, we put Ann Arbor. I think
You're going to Ann Arbor? What are you going to Ann Arbor for?
No, the
Oh, you're not personally playing in Ann Arbor.
we thought there was stadium cleanup the morning after
Oh, that'd be wretched. So City had that this week. They had stadium cleanup the morning after homecoming. Poor City. Sucks to suck.
just colors. Shading, actually.
Got about 9 of you in on the pair deck, waiting for a few more to join in. So you got a couple things you got to do. You got to figure out the distance traveled in that time from 4 to 8. Separately, you need the displacement in that time from 4 to 8. Hopefully, you know how much time passes from 4 to 8.
That's old people. You get like more.
Until my.
What?
What's her sister's? Oh yeah.
Oh,
Is it called? What's it called? I passed that on the way to my grandparents' house this weekend. I was like, oh, that looks cool. I also passed some like ocean, like something weird. On a gravel road in the middle of nowhere.
what the hell? Let's see. When are we getting our flu shots here? Yo. October 22nd. Say boo to the flu. Got 10 of you in. Got 21 of you signed up for the pair deck. So hopefully the other 10 will answer and the other 7 will join. That'd be super great. So you're answering both pieces on here right now. What is the average velocity? What is the average speed? You're doing a 2 for 1. We're seeing if you can get that sorted out.
This is sometimes it's a little weird. I'll try to find it. I don't want to say everything. The last one is literally so fun. It looks so messed up. It says 5 a.m. Look at that. Doesn't it look like I know it's not. It looks like a boy. I know. That's what I think. Look at his face. But it's and it was 5:21. And I said, "Open it." It kind of looks like this. One of those faces. That's literally what I was so confused by it. But also, like, his face is so funny. Look at this. Okay, I pull it. Yes. They said, slide. I said, absolutely not. Is that the same apartment classroom? That kid scares me. He's disgusting.
Pierre deck.
I need to go home and check that out. That's my dad's. Sometimes when I'm like, I'm spraying myself with it, I just go upstairs and I should bring them to Christmas. Should I bring them to Christmas? I think we should. Oh my god. Wait, is Lila like friendly my dogs or she's like Chip will probably be scared of your dog. He's scared of little dogs. But like they'll like each other. No, I swear my dogs won't like that. Abby will have to introduce her, so like I'll have to put her on a leash first, but then she'll be chill. But Abby
All right, so here's some of the different answers I've got going on right now. I've got freeze. I've got -1/4 meter per second for F and -2 meters per second for G. I've got -0.5 for average velocity. I've got 2 for speed, 3/4 for velocity, and 2 for speed. So run through with your neighbors and see what's up with that.
Sometimes he got stuck under the fence. So whatever shoved him under the fence, and the fence was good. The Anderson's dog, so that's how we used to play with him all the time because they had wrestling this food. It was like so chill. Like 5 years ago. And we used to do it, and then they're not with me, and so we decided to do that. And we were so rude. And Abby was trying to break the board because Chip was getting hurt, but she couldn't do anything because she tiny little fat dog. Like, I know.
You need up your game.
We stopped living up to it because it costs $1 million to get stitches on dogs. And Abby has gotten like 2 hip surgeries on both her hips because she hurt them. Yeah, she heard him playing with whatever. Like, that dog is not okay. And the little dog is like, this is learned by fast. I'm hot. My perfect is hot. She tried to turn on the temperature. You know how to do this? Next question on the very average speed and like the odds speed. I didn't do that. What is this? Did I do it backwards? Do what?
I'm still waiting for a few of you to join us. I'm showing you some of the various answers that we're getting. I've got a -1/4 meter per second for the average velocity and a -2 for the speed. Here I've got a -0.5 for the average velocity, 2 for the speed. Here I've got a 3/4 meters per second for the velocity and 2 for the speed.
Wait, so did you get 1/2 for both of them? So I really did. This is the displacement here.
Wait, what was the question?
This is F and G. These are our answers. Let's see, I can do this. These are people's answers in response to these two questions. Average velocity from 4 to 8, average speed from 4 to 8. Oops, I got it all frozen up. No, he is not here. No worries. So again, you can kind of go from the data table for this. We need the position at 4. That's 7 meters. We need the position at 8. That's 5 meters. Okay. And then if we want the change in position, AKA the displacement, why are there two names for the same thing? I don't know. We're going to go P8 minus P4. So 5 meters minus 7 meters. That's -2 meters. That's the displacement. Okay? So then when I want the average velocity, I got to take that -2 meters and 4 to 8 seconds. The time there is 4 seconds. So this is going to shake out to be -0.5 meters per second. But then in terms of the distance traveled, if I'm looking on the graph, there's 4 seconds. So 4 seconds is right there. 8 seconds is right there. So if I look at the distance traveled, here I'm going to go, goodness. This part looks like 3 meters. This part looks like 5 meters. It's not caring positive or negative. If it's a Fitbit or a step counter, it just cares about the distance you traveled. So that's going to be 8 meters in 4 seconds. And that's where we get 2 meters per second for that answer. So the average velocity is going to take into account that there was a change in direction. The average speed does not care about that change in direction. It's just tracking the total distance that this thing traveled. All right. So that will definitely feature on the, whatchamacallit, the buffet test, if you will, on Wednesday. Can you distinguish between average speed and average velocity? can you distinguish between the distance traveled and the displacement? All right, and then what I'm having to do here is we're going to switch gears a little bit and roll back over to the multiple representations of motion. So if you look at this sheet, we've got 1 and 2. You're given the position time graph. It's got 3 segments. What should the velocity graph look like? What should the motion map look like? What should the written description look like? Okay. Or you're given a velocity graph, or you're given a description, or you're given a motion map. And I want to get us a little more practice with that.
Does September have a 31? It has just 30. Like how many days is it?
I don't know why I'm not doing like that now.
How many people do you think there could be? It's just like
All right, so what I'd like you to do is come on up and sign your group up for one of these, number 1 through 8, and then grab a whiteboard and put your answers together on that whiteboard. Okay? Your buggy group.
What is our group?
Yeah, which one?
Come on, groups.
hey, we're literally not in a group together.
I poop.
Is this supposed to be? Is this supposed to be the
Does your buggy buddy?
Okay.
Buggy buddy board. Come on, slow internet. Cripes.
So here's your buggy buddy. There's no group called Drew. Yeah, 2 groups per problem because there's only 8 problems. And we have 1, 2, 3, 4, 5. We have 15 groups.
Okay.
So this is with your buggy
Can
buddy.
you put Rachel's name on my?
Buggy buddy.
Oh.
And then you need a whiteboard. We got like 10 minutes. You should get ish to done on it. Oh, this is frozen. All right, sorry. Here's my notes back here. Congrats on that note.
So it's straight line exactly.
Yeah, and it's going down.
Oh, okay.
So it's like straight line going like down, and then